Good morning. Today we are going to take up two very important questions of this exercise 6.3. The first one is the question number 18, which says that for the curve y equal to 4x cube minus 2x raised to power 5, we have to find all the points at which the tangent passes through the origin. Now, what's so special about this question? We have to see how is this question so different from the rest of the questions which we have taken so far. Now, please note here that in this case, we don't have to find tangent at the origin. What we are required is to find the points at which the tangent passes through the origin. Like it's the case like if the curve is like this. So, suppose there is a tangent which is common to two or more points, something like this. Then this tangent will pass through the origin. Okay, so we have to find all these points at which the tangent or the common tangent passes through the origin. So, the procedure is exactly the same as what we have been doing so far. So, let's start. Differentiating one, which is the given curve, with respect to x, we get dy by dx is equal to 12x square minus 10x raised to power of 4. Let's name it equation number 2. Now, let the required point tangent be at the point x0, y0. So, when x equal to x0, from equation number 1, we will have y0 will be equal to y equal to x0 cube minus 2 x0 5, which we will call as y0. Now, finding the slope at the point x0, y0, we get dy by dx at x0, y0 is equal to, just simply substitute x0 in place of x here. So, we get 12 x0 square minus 10 x0 raised to power 4. Therefore, equation of the tangent at x0, y0 will be y minus y0 is equal to slope, which is 12 x0 square minus 10 x0 raised to power 4 times x minus x0. Now, the tangent passes through the origin. So, where will we put this 0, 0? We will be putting in place of x and y. So, substituting 0, 0 in place of x and y, we get 0 minus y0 is equal to the slope into 0 minus x0. This minus and this minus gets cancelled, and then we get 4 x0 cube minus 2 x0 5 is equal to the slope times x0. Now, here in place of y0 we have written this point. Now, taking this term to this side and this cube term to the other side, we get 8 x0 raised to power 5 is equal to 8 x0 cube, because here we have 10 minus 2, which is 8, and here this becomes 12 minus 4, which is 8. This gives us x0 5 is equal to x0 cube. Now, here we will not cancel out the common cube term on both sides. We have to report all possible values of x, and for that we will take it common. So, what we do is take the right hand side to the left hand side, we get x0 5 minus x0 cube is equal to 0, which gives you take x cube common, you are left with x0 square minus 1. Factorize this, you get x0 cube is into x0 minus 1 into x0 plus 1 equal to 0. Equating it to 0, we get either this is 0 or this is 0 or this is 0, which gives us three values of x0, which is 0, 1 and minus 1. Now corresponding to these three values of x naught, we have to find the three values of y naught. From the equation of the curve we have y naught is equal to 4 x naught cube minus 2 x naught 5. When x naught is 0, this gives us 0 minus 0, which is 0. So the one point is 0 0. When x naught is 1, substituting we get y naught as 4 into 1 minus 2 into 1, which gives us 2. So the second point comes out to be 1 comma 2. And the third case is when x naught is minus 1, y naught becomes 4 into minus 1 cube minus 2 into minus 1 raised to power 5, which gives us minus 4 minus of minus 2, which is plus 2, is equal to minus 2. So the third point comes out to be minus 1 comma minus 2. Thus the three required points are 0 0, 1 comma 2 and minus 1 comma minus 2. Now let's take the next important question, which is question number 23. It says that prove that the curves x equal to y square and xy equal to k cut at right angles if this condition is satisfied. And what is the condition? 8k square equal to 1. Now let's start from again the very basic, that is we need to that the tangents to 1 and 2 will be perpendicular to each other if the curves cut each other at 90 degrees. Okay, so now what is the condition which makes the tangent perpendicular to each other? That the slope of the tangents to this curve as well as this curve will be negative inverse of each other. Now let's find the slope of the tangent to 1. So differentiating with respect to x, we get 1 is equal to applying chain rule 2y dy by dx, which gives us dy by dx is equal to 1 upon 2y. Let's call it equation number 3. Let us now find the slope of the next equation, which is xy equal to k. We can write it as y is equal to k upon x, which is equal to k x raised to power minus 1. Differentiating with respect to x, we get dy by dx is equal to minus k x raised to power minus 2, which is minus k upon x square. We call it equation number 4. But the tangents are given to be perpendicular. So by 3 and 4 we get 1 upon 2y, which is the slope of the first curve, into minus k over x square, which is the slope of the second curve, is equal to minus 1. This minus and this minus gets cancelled and we get 2x squared y, which we take it this side, is equal to, we are left with k. So we get 2x squared y is equal to k, which we call at equation number 5, and this is the condition that the given two curves intersect at each other at 90 degrees. Now this condition will be satisfied at the point of intersection of the two curves 1 and 2. So let's first find the point of intersection. For that, let's consider the two curves. Curve 1 is x equal to y square and curve 2 is xy equal to k. From here we get x equal to k upon y. Substituting this in this curve, we get y square is equal to k upon y, which gets solved to y cube equal to k, and hence y is equal to k raised to power 1 upon 3. Substituting this value of k in this expression, we get x is equal to k upon, in place of y we will be writing k raised to power 1 by 3, which gives us x is equal to k raised to power 2 by 3. Thus the point of intersection of the two curves is k raised to power 2 by 3 and k raised to power 1 by 3. Substituting these values of x and y in 5, which is the condition, required condition, we get 2 into k raised power 2 by 3 whole square into k raised power 1 by 3 is equal to k, which on solving gives us 2 into k raised power 4 by 3 into k raised power 1 by 3 equal to k. These two get added and it becomes 2 into k raised power 4 plus 1 by 3. This k comes down upon k is equal to 1. This becomes 5 by 3. You take this k up, it becomes 2 into k raised power 5 by 3 minus 1 is equal to 1, which gives us 2 into k raised power of 2 by 3 equal to 1. Finding cube of both sides, we get 8 into, over here this becomes k square equal to 1, which is the required condition, hence proved. Thank you.